Okay. Because what we're looking at today is inverses, the inverse of a function, and finding inverses. Now, we know the vertical line test. Y'all have done that in Algebra 1 in 8th grade and going on. And it's pretty much to determine if a graph is a function, determine if it is a function, it cannot have a vertical line, a line straight up and down, cross the graph more than once. Because if we have a graph and we can draw a vertical line, a line straight up and down, and it crosses the graph more than once, then it's not a function. That was the vertical line test. And we went over that in Algebra 1. Now, there's also something called the horizontal line test. And what the horizontal line test is, it tests to see if it has an inverse. An inverse. Now, the reason that this works the way it does is if we have a normal function. I'm going to need a little more space than this. Because we have the domain. These are our x values, because when we plug the domain, the x values into the function, it takes it from the domain to the range, our y values. So for any function f of x, we take a domain and x value to a y value. Because we plug a value in, we get a value out. And we can call this f of x. Now what an inverse does, the inverse function, is that it's taking a value from that same range and taking it back to the domain. It's going the other direction. We're essentially flipping the x and y values. So questions on this here. So we good with this so far? Yes, kind of, we're flipping the x and y values. So if we were looking at a normal function here, so the x value, we'll say, is at -3, or not -3, can't be a -3 there, 3, and this is up here, we'll say, is at 4. It doesn't really work for this function because it's technically a cubic. It should be way higher than 4. But for case in point, we have this here. So if we flipped it, really this value for the inverse is going to now be at 3 on the y and 4 on the x. So what it'll be looking like is something like this here. So it just flipped. Y'all kind of see that there? And what essentially is happening is with this flip, so I can actually line this up, let's say 2 and 4 for a quadratic. And this over here is at -2, 4. Let me use a different color for the -2. Just make it a little bit easier to see. 2 and 4. Well, for this blue 2 and 4, well, the x is now going to be at 4, and the y is now going to be at 2. Y'all can kind of see that there? But that means for our other one over here, -2, 4, well, the x value is at 4, the y value is at -2 down here, yes? Wait a minute. Does that pass the vertical line test? No, so it's not a function, correct? So that's where the ingenuity of the horizontal line test comes from, is the fact that, I'll erase this here, because y'all can kind of see once we kind of did that flip, it doesn't pass the vertical line test, it's not a function. Its inverse is not a function, correct? But does that parabola pass the horizontal line test? Well, no, it crosses more than once, right? So with inverses, if the original function fails the horizontal line test, its inverse would fail the vertical line test, saying it's not a function. Does that kind of make sense how that works? And that's kind of where this is kind of neat and interesting, is the fact that for us here, if the function, the original function, doesn't pass the horizontal line test, its inverse won't be a function, because the inverse would not pass the actual vertical line test. Kind of see where that's coming. That's why this is nice. That's why this is kind of neat, that it does work this way. And now what we're going to be doing, I don't like how they do these first few, but we'll have to do them with the online software because it's going to require to have it in this form, variables, as y'all figured out at this point. If it doesn't line up exactly the way that it wants it to look, it marks it wrong. Yes, if you put y instead of x, it marks it wrong. So we're going to do this here in the format that they're going to have it for these first few. Because what we're doing and the steps that we'll do will be correct, but we changed the notation a little bit. For when you do the test, it'll be a little bit different. And we'll see it, and we'll come into contact with it here in a little bit. Now, what we're going to be doing first is we're going to start off with finding the inverse of the function, finding its inverse. And then we want to find the input when the output is -7. So find the inverse when we have the inverse function of -7. So let's just start off with this here, and it'll make more sense as we work with this here. And I believe at this point you've found inverses before. Because when we talk about finding the inverse of a function, we rewrite it like this here. We replace f of x with y. And then normally we would switch x and y, and then we would solve for y. That's kind of how we would do inverses. But the way they want us to do this here and the line up with the homework, what we're going to do is we're going to solve this for x. We want to get x by itself. Okay. So looking at this here, what do I need to do to get x by itself? -3 from both sides. Okay, I need more space. And now what? Divide both sides by 2. And we get x is equal to y -3 over 2. And that's it. Any questions on this here? We're good with this here? So we get this here, which when it says find the input when the output is -7, where if we didn't know what the inverse was, or what the inverse function here is, we would have had to set this up as -7 equals 2x plus 3 and solve for the value of x. But with the inverse, input is equal to -7 minus 3 over 2. It's already solved for it. So at this point here, we just need to simplify this. Well, -7 minus 3 is -10 divided by 2 is -5. Questions on this here? So really it's just saying our normal function, when we plug -5 in for x, we would get -7. For the inverse, when we plug -7 in for x, for the inverse, it would get us back to -5. It's just switching the input and output. So, as I've been kind of emphasizing for most of this here, depending on what we do, if it says solve y equals f of x for x, it's wanting your answer in terms of y, because you're wanting to get y by itself. If it's saying find the inverse, find f inverse of x, f to the -1 of x, then it's wanting it in terms of x. So that's kind of the main difference to be looking for when it states that. On a test, I'm just going to be asking for the inverse. I'm not going to be asking to solve this thing for x. I don't want you to do that. I just want you to find the inverse. If I ask for inverse, we're just finding inverse. So, first off, in either way, we need to change f of x to y. F of x and y are unanimous. H of x and y, any of those there are unanimous with y, our output. Now for this here, again, we're solving for the value, or solving for x. We're trying to get x by itself. So the first thing we can do is we can add 5 to both sides. Which would give us y plus 5 is equal to 3x. And then last but not least, we can divide both sides by 3, telling us x is equal to y plus 5 divided by 3. Any questions on how we found the inverse, essentially? Now we just need to plug the output in, which would be our negative 11 plus 5 over 3. Well, negative 11 plus 5 is going to be negative 6 divided by 3. It's going to be negative. So input is what goes, output is what comes. And it's these same type processes. You're solving for one side or the other. And we can do this for almost any function. There are just some functions we have to add restrictions to. So as we saw at the beginning, our quadratic, our U-shaped function, does not pass the horizontal line test, correct? But we can restrict it. So instead of having a full U, is I can stop it at the vertex, the bottom part of the U, and only include the right side or the left. So we can restrict it to only half the function, which gives us an inverse. The same thing is true with sine, cosine, and tangent. So I have a feeling we're good with this type function here, yes? These linear base, or do we want to see one more? We can see one more, that's fine. What do we do first? Right, yes. So really, to solve it for x, we just had to add 2 to both sides. There was nothing else that we needed to do with this. Now, the other part is to find the input, or puts, when the output is 2. So we'd have 2 plus 2. So x is equal to 4. Yes. Yes. Questions on this here? Okay. Now this one here is moving it up a little bit, because now we don't have a linear function, we have a what? An x squared. Y'all remember the name for this type of function? Starts with a Q. Quadratic. It is a quadratic. Now, technically speaking, this does not have an inverse because quadratics are a U-shaped graph. They don't pass the horizontal line test. So there would be restrictions, but we're not going to worry too deeply into that yet on those restrictions. We're going to go on and just follow this here. So if we were to look at this, it'd be y is equal to 2x squared. So what do we need to do first to get x by itself? Yes? Yes. We should divide both sides by 2 first. Which would tell us that x squared is equal to y divided by 2. Now, what would we need to do next? We do need to get rid of the square because we need x instead of x squared. So to remove a square, we square root both sides. Because a square root and a square will cancel, leaving us with x is equal to plus or minus the square root of y divided by 2. I have a feeling I will double check before y'all leave, or definitely before I assign the assignment, because there won't be one immediately after today's lesson. It'll be after Thursday, once we finish up this 5.7. But I believe that we can leave it as this here, plus or minus the square root of y divided by 2. It's not going to ask you to rationalize it and put it in simplest form, from my understanding, because we would need to get the fraction out of the radical. But I feel like this here is, if I'm remembering correctly, is one of the answers. It allows you to do this. But again, whenever we square root both sides, we have to put plus or minus, which is different than squaring or putting both sides to an even power.
I thought it should be an even number.
It is on this, because we square rooted both sides. Because in the last week when we talked about solving, we put both sides to the second power or the fourth power. And that's going to be different than square rooting. Because when we put both sides to the fourth power, we're canceling out a radical, and the numbers inside the radical cannot be negative. But the numbers coming out of a square can be positive or negative. And that's the kind of tricky thing with it, making sure to differentiate the two. So when we square root both sides, we need the plus or minus, or an even root of both sides, we need the plus or minus. But we put an even power to both sides, we don't need it. It's such a tedious difference. It's almost a little bit dealing with semantics. You should ask Ms. Wilson today. Now, the only other part that we need to do for this is checking what the input, or finding the input when the output is 2. Or inputs. So 2 divided by 2 is square root of 1. And because of the plus or minus, we technically have plus or minus 1. Questions on this here? All right, we're going to keep doing these here. Now we have a cubed root. Or not a cubed root, a cubic function. Because we have x to the third. Now, for most cubed roots, they will have an inverse, but there are a good number that won't. Now for almost, actually I think I'm willing to make the statement, for every cubic that only has x to the third, we don't have x squared, we don't have x, we have x cubed in a number like this here, it will have an inverse. I can say that for certain. But not every one that has other x squared and x terms, it could have an inverse, but it's not guaranteed. When it's just x cubed in a number, it's guaranteed to have an inverse. And if you ever wanting to make sure that it does have an inverse, the best way to do that is graph it and see, does it pass the horizontal line test? Yes. Especially if it's on the ACT, determine if the following function has an inverse, graph it, immediately graph it. Because the graphing calculator will graph it. Does it pass the vertical or horizontal line test? Does it cross more than one spot? If it does, okay, it's not an inverse. It doesn't have an inverse. If it doesn't, then it will have an inverse. It has no inverse. Because most likely, if it doesn't have an inverse, it's going to give you the option to say it does not have an inverse. You'll have to go through the steps to find it. Now, looking at this here and kind of, again, referencing back to the ACT, well, since I know that this is a cubic kind of with the last one, since the last one was a quadratic, what did we end up using at the end? Square roots, yes? So what do I know for certain? Cubed roots, yes? So on the ACT, where it gives you 5 answer choices, any one that doesn't have a cubed root is gone. It doesn't work. Well, that's kind of why am I even mentioning this, right? Well, looking at this here, we graphed it, and okay, it has an inverse, right? And then I looked at that, okay, I'm going to have a cubed root. Have I actually done any math solving? No, but I'm taking answer choices out, yes? That's what's nice with multiple choice math tests, is if you know what you're looking for or what to be expecting, you can start throwing answer choices out, okay? And it's helpful, and it saves time. Now let's go on and solve this. So what's the first thing I need? -3 from both sides. Whoa. I knew I was writing that wrong as soon as I started writing it. Okay, so we started moving everything over, and we've got most everything on the one side. Him? -1. Yeah, we can divide it by -1. We can also multiply it by -1. Either one works, because dividing or multiplying by 1 doesn't change anything. Just the -1 makes it the x cubed positive. Now our y -3 is going to become what? Well, -y plus 3. No, and it's fine. I mean, we could write it out as -1 on bottom. But what we know is that when we divide by divide by 1, y divided by 1 is still y. -3 divided by 1 is still -3, yes? When we divide by the -1, we're changing the signs. And I feel at this point, y'all are comfortable enough that we can do that sign change without having the step in the middle. And that's really what we're doing, is we're flipping the signs of everything here. Since x cubed was negative, it's now positive. Since y was positive, it's now negative. And since 3 was negative, it's now positive, yes? Well, now the only thing that's left is 2. And we need cubed root. cubed root both sides. And the cubed root and cubed will cancel out. X is equal to the cubed root of negative y plus 3. Now only even roots, when we take the even root of both sides, needs the plus or minus. Odd roots do not. We can take the odd root of a negative number. Actually, odd roots, it's just, we have one answer. When we take an odd root of both sides, it's just one answer that we could have. Because negative 2 to the third is negative 8. 2 to the third is 8. So we don't have that case where we get the same thing like with squares, where negative 2 squared is 4, and 2 squared is also 4. We don't have that lineup. We don't have that matchup. So we don't need the plus or minus. And right there is our answer. Last but not least, we need to find out what the input is when the output is 2. And at this point here, I would just plug this into the calculator to get your answer. X equals 1. It's good to show your work to prevent errors or kind of little mistakes. It's good to show your work, especially on my tests, because it helps me know where you messed up and kind of to help out with partial credit. But on an ACT or timed state or standardized test, plug that thing in. Because especially on the ACT, which y'all know is coming up soon, you're not going to get points for writing things out. It'll help to make sure that if you need to keep it straight, write it out. But type in the cubed root of negative 2, or negative parentheses 2, close parentheses, plus 3. Type it in. It's saving you time. Okay. Now that we got through that part, finding inverses, this is where we're actually going to flip the x and y that I talked about earlier. So if we want to find the inverse, step number 1 is to replace f of x with y. That is going to be step number 1, is to replace f of x with y. Step number 2 is going to switch x and y. Step 1 is to replace f of x with y. Step 2 is to switch x and y. Step 3 is to now solve it for the value of, or solve it for y. We want to get y back by itself. Yes, we would plus 1 to both sides. So we would get x plus 1 equals 3y. Exactly, we would divide both sides by 3. And we'd have y is equal to x plus 1 divided by 3. So our first main step was to rewrite f of x as y. Our second step was to switch x and y. Our third step was to get y by itself, which we did. Now the fourth step, last step, is that we need to switch y to f inverse of x. And that last kind of step is really signifying that this is the inverse function. Yep. Because our last step is going to be rewriting y as f inverse of x. So this here is the final answer. And that's it for this here, because it just asked us to find the inverse. It didn't ask us to find anything else. Now, if it asks us to find the input given an output, here we would be saying that the input that we're looking for the original function is going to be our f inverse of x. Because the input x for this here is the output for f of x, and the output for f inverse of x is the input of f of x, because they're going back to each other. Questions on this here? Find the inverse. I'm not worried about graphing. So our first main step in this here is to rewrite f of x as y. And then what is our next step? We need to switch x and y. Right, then we need to get y by itself. So we would divide both sides by 2. Which will tell us that y is equal to x over 2. Now what? Inverse of x is equal to x over 2. All right. We're going to look at one more today. And I feel like this one here is one that you're comfortable with doing, yes? So let's look at this one. F of x equals 1/3 x minus 2. So let's just walk through the steps. First step would be what? Yes. Switch x and y, so we get x is equal to 1/3 y minus 2. Yes. I'll scroll back up just a bit. Yes. We can divide both sides by 1/3 and that'd be fine. But I'm a little bit hesitant on it, and it's not that it's wrong, because that's exactly what we're going to be doing. But the issue that we might have is that we would have x plus 2 divided by 1/3. We have a fraction in a fraction. From our chapter on rational expressions, we know that doesn't work well. We can't leave it as a fraction in a fraction, correct? So I want to stick, especially with fractions, and we're wanting to try to remove them. What it's really saying is that I have 1 divided by 3, yes? So the opposite of division is, if I multiplied 1/3 by 3, I get what? 1, yes? Because 1/3 times 3 is 1. So these will cancel. And if we multiply this by 3, right, we would distribute. 3 times x would be 3x, and 3 times 2 would be plus 6. and we get this here. Questions on this here?